Hi everyone and welcome back to Newegg TV. My name is Paul. Today we have a special guest. This is JJ from ASUS, and JJ, thank you again for stopping by.
Thank you very much for having me.
What we're here to talk about is the ASUS line of Z77 motherboards, and specifically what this video is all about is overclocking on the Ivy Bridge on the Z77 platform using an Ivy Bridge processor.
Yes.
Which is just now out, at least it will be by the time we post this video. And JJ, for starters, which processor are we using in our test bed today?
We're using pretty much the flagship for the performance segment for Ivy Bridge, which will be the 3770K.
Okay, and as compared to the Sandy Bridge line, which was out last year, that would equate somewhere along the lines of a 2600K?
2600, 2700K part, yes.
So spiritual successor. That being said, what are we going to go through today for overclocking?
So first and foremost, I think want to paint the picture in terms of what are the expectations for this platform. There's been a number of considerable changes that have occurred in relation to the lithography. So that's the actual fabrication process in terms of the CPU. We've gone now to 22 nanometer. That's the first generation of design incorporating the 3D transistor, a tri-gate design that Intel's incorporated. And this has changed in terms of how the CPU responds to, let's say, its heat and voltage sensitivity. In previous generations, we saw, let's say, every time you drop down in terms of the lithography process, temperatures would drop down, so effective TDP, heat output, would drop, and you would more or less be able to keep the same voltage or apply more voltage to keep increasing the frequency. Such as in Sandy Bridge, right, we saw scaling. If you had a capable quality cooler and you had a good CPU, you could effectively, go 49, 50, 51, 52x in terms of the frequency, right? So 52 times 100, 5.2 gigahertz. For this platform, it's actually going to be a little bit more conservative, but that doesn't necessarily paint the entire picture in terms of what the outcome performance is going to be. But there are definitely some changes to take into consideration.
So as you mentioned, frequency boost, which is what a lot of people shoot for when they're going for overclocking, is what frequency can I get the processor up to. First off, maybe can't hit quite the frequencies that we were seeing with Sandy Ridge, but that does not necessarily equate to a speed difference. Even with a lower clocked Ivy Bridge processor, it's still probably going to be faster than even a higher clock Sandy Bridge processor.
That's correct, and that's because of what's called CPC increases, and this is because Ivy Bridge is architecturally just a faster part than your pre-existing Sandy Bridge part. So you're 100% on the ball there. So the overall realistic, I'd say, air frequency that you're going to be looking at in a high performance like push and pull fan configuration is going to be probably somewhere about 4.8 gigahertz. But potentially, if you have outstanding CPU cooling configurations, maybe a little bit more than that. But with that, voltage is going to be an area of concern. So while we're going to go through a couple of steps, at this point I want to actually show you an aspect of consideration relative to voltage and how that affects temperature.
Okay.
So we've already gone ahead and completed actually some results beforehand. So let's go ahead and open up one of these results. So this is 4.8 gigahertz, okay, achieved. And if we go ahead and take a look here at Ada and the corresponding voltage table, we can see that actually we're achieving this 4.8 at a very nice voltage, okay?
1.33?
1.336, so definitely not that high, right? Compared to previous generations, you might have been looking much closer to, let's say, about 1.425 to 1.45. But we can then take a look here at our red box, and we can see that the corresponding outline temperature, it's pretty high. And this is with a high performance dual fan configuration. So keeping this in mind, you really wouldn't want to actually push that much more voltage or even potential frequency out of this part because you're essentially hitting a very, very high temperature ceiling. Now, I'm also using Ada in terms of Ada64 for stress test validation because it's pretty much one of the only applications on the market that fully understands the Ivy Bridge CPU. And what I mean by that is that it's actually utilizing instructions such as AVX, AES, SSE, which take into account all the complex logic that's on the CPU. If you use unvalidated stress tests like, let's say, like OCCT or Prime or Lynx or things like that, for one, you could potentially damage the CPU part, especially under this generation. But you're not also actually testing all parts of the CPU architecture. So it's not as valid of actually a stress test measure. But keep in mind, if you did try to run those, the heat level is even going to be considerably higher to the point that your cooling solution is probably going to give out, or you could potentially damage the CPU. So we definitely do want to stress at this point that you do not want to, for one, use those unvalidated applications, and two, I would be very cautious to not exceed a voltage table of 1.350 and staying closer to about a 1.325 marker.
So for those of you overclockers out there, bear this information in mind. It's very important. First off, don't worry, you're still going to get the speeds that you want if you're going to be running your benchmarking tests. But don't be as aggressive with voltage as you have in the past. And definitely bear in mind that if you are going to be running a stress test, a lot of the free-to-download stress tests that are out there might not be as effective or even potentially dangerous. You might want to go with something like IDA 64.
Yeah, and I always do stress too, at the end of the day, you should stability test with the applications that you're actually utilizing. If you're a content professional, you're using Photoshop, run a whole bunch of complex filters and actually test to see if you have stability underneath that. The actual wattage, which actually is down here in this table in terms of ADA, can actually be sometimes equal to that of a very high load synthetic application like even Prime. So you'd be surprised in terms of how those complex real world programs can stress a system. But use a combination of things that actually make sense. Like, so if you're a gamer, go in, jump into Battlefield 3, run through it, right? Or run through, different types of benchmarks, because the temperature characteristics are going to be very different. Most games don't go over about a 50% game utilization pattern. So the effective temperature is going to be actually much lower. So at the end of the day, you should use what you're actually going to be running on your system with that overclock. Stress tests are good in terms of helping define worst case scenario, but at the same time, you want to be sensible.
Okay, and for your personal recommendations for folks out there who might be going into overclocking, what would be the max voltage that you might recommend, as well as a max frequency?
Max frequency really is, I wouldn't advise targeting anything more than 4.8, and with those voltages, 1.325 to 1.350.
Okay, and very important, because with Sandy Bridge we saw people going up to 1.4, 1.45, 1.5 even.
Yeah, even 1.5 like you noted, especially with very robust coolers, and we don't want anybody to damage their CPU here. Definitely want you to get more performance. And with that, let's talk about some of the easy ways that you can get more performance with our series of motherboards.
Okay.
So, for multiple generations, we have had our dual intelligent processors design. This is one of the key parts of that is our TPU technology, and we've had a great and easy switch on the motherboard. So on a lot of our motherboards, there's a little switch on there. It's called the TPU switch, and when you flip it on, this gives you a quick and easy way to, let's say, overclock your CPU to about 4.2 gigahertz. So you get a nice and quick, easy bump. So if you're uncomfortable overclocking the platform, but still want to take advantage of Ivy Bridge in an unlocked part, like a 3570 or a 3770, just flip that switch and you're good to go. What we want to show, though, is going to be the next step in the TPU process, which is Auto Tuning Extreme. This is going to be a real-time dynamic process that accounts for our CPU configuration, our cooler, and it's also going to incrementally be very sensible at how it increases the voltage, because it's not going to use a fixed voltage. It's actually going to use an offset voltage, and the benefit of that is that as our frequency goes up and down, the voltage is going to go up and down with it.
And that's an important power-saving feature of we saw it with Sandy Bridge, we're seeing it with Ivy Bridge now as well, that when it's actually not utilizing the CPU, it's going to drop those values down, it's going to save power, and
also reduce temperature and overall long-term wear to the part, right? We don't want to have to run more voltage consistently to that part than we don't want to, right? If you use a manual fixed voltage, if it drops down to, let's say, 1.6 gigahertz at idle, and you're still feeding at 1.45 volts, that doesn't make sense, and you're actually adding more potential voltage degradation to the CPU part. So you want to be sensible.
Okay.
So let's take a look and see what type of results we're going to get with actually Auto Tuning Extreme.
All right, and auto tuning you demonstrated with Sandy Bridge. If you guys want to check out that video, it's a little bit older now, but this is. Have you guys done some updates to auto tuning?
We have actually made a couple of little bit changes. For the most part, the process is going to be pretty similar. The great thing about it is that it is going to be a full real-time process. So in it being a full real-time process, what that actually means is that you're actually making changes to the actual multiplier, to the voltage, and we have a full stability test that's going to be occurring real-time in this. So let's go ahead and click on this actual Extreme button. We'll click Start. And this is going to initially first load a baseline profile of about 4.2 gigahertz. It will reboot the system. And when then it comes back from that, we're going to actually show you what the scaling process looks like.
Now, with your experience thus far running auto tuning, about like how many different iterations does it go through before it fixes on a stable overclock?
It's actually going to vary depending actually on your cooling configuration. And at each point that it does make a sizable increase, you can stop it. So I'd say in terms if you have an outstanding cooling configuration, it's probably going to go through maybe 3 to 4 steps, which will be somewhere between about 7 to 10 minutes. If you decided to stop right after this reboot, then you could stop it, and that's essentially only taking maybe like 1.5 minutes to 2 minutes.
Okay.
So it's really up to you. And same thing in relation to frequency. Here we've got a Corsair H60 with dual 120 120mm fans. So it's a pretty robust cooling configuration. So we're going to be probably looking at the top end scale of what auto tuning is going to be able to provide at somewhere between probably about 4.5 to about 4.6 gigahertz.
Okay.
But if you were just running, let's say, the Intel retail heatsink, which is a much more basic, low-profile heatsink, of course, that's going to be a considerably lower frequency and temperature. But at the same time, let's say you jumped onto Newegg 6 months later, you saw a recommendation for an awesome CPU cooler, you could go ahead and run the auto tuning process with that new cooler and go ahead and get a new higher result.
Okay, and so this is actively going to be monitoring the temperature, so based on whatever cooling configuration you have, it's going to actually make the adjustments based on that. So once it hits a temperature threshold, it's going to cut it off and say, here's the most that you're able to get with auto-tuning.
Correct. Temperature and stability threshold.
Okay, now, and if you were more of an enthusiast, could you use the auto-tuning to sort of give yourself a baseline overclock and then go further from there and tweak it to your preference?
100%, and that's actually a great way to look at it. With auto-tuning, if you're new to the platform, right, which everybody essentially is going to be with Ivy Bridge at this point, you can learn a little bit about how your system is going to scale. What's the temperature look like? What's the voltage look like? And you could use the top-end value that it provides you as kind of like a baseline, and then go from there and go ahead and make some adjustments, whether it's within the AI Suite 2 interface or whether it's within the UEFI. Now, we can see that it originally popped up there and it gave us actually a baseline of about 4.2 gigahertz, right? And so now it's going to go ahead and continue the real-time process. And we can actually hear the fan ramping because if we open up Task Manager, we can see that real-time and actual stress test is occurring and all the cores are being fully populated in terms of the load. So we can see all cores are being stressed right now. We're at 4.3. We've made a little bit of a jump up, and now it's going to go ahead and continue that process. So the initial part has said, okay, I passed that portion. That was stable. Now let me go ahead and increase it. We're now at 4.4, and we're going to go ahead and reapply the stress test again, and it's going to continue through the process. And in the background, it's making adjustments to things like voltages, just like you would normally do if you went into the UEFI and you made those changes.
Okay.
So that's actually normal. So that crash is indicating that it reached the stability point in terms of the threshold going, hey, I'm not stable at this point anymore because maybe there was too little voltage. So the board's going to go ahead and take all this information and then it's going to repost and from there continue forward. And even the boot timer, right, which is normal, let's say after a failed reboot or something along those lines, it's 30 seconds. We're going to see it's actually dropped down. It's only about 5 seconds.
Oh, okay.
Because we've taken all that in consideration. So that reboot cycle is going to go through, and then it's going to go ahead and continue that scaling process. Now, part of the things that occur, as you can see there, it's reduced, right? Part of the reason why this reboot process occurs that not a lot of people understand is that there's a concept that's called memory training.
Okay.
Memory training occurs every time you post the system, and there's different values of interaction between the memory and the CPU. And at times, in between different actually reboot cycles, you might have different scaling levels. And this is what auto-tuning is also taking into effect in between the times when there's no stability as opposed to when there is stability.
So it's going to run through some iterations within the operating system, get to a certain point, and then it'll actually reboot to do some more low-level UEFI changes, and then we'll continue the process from there.
Yes, and now we can see at this point it's given us 4.43 gigahertz because that was overall the last rated high overclock that was successful, right? And at this point, if we did want to stop, we could go ahead and click stop, but we're going to go ahead and let it continue until it gets to its completed result. Now keep in mind that at any one of these stages, if for whatever reason you didn't want to continue to take advantage of our AI Suite 2 software, once the auto-tuning process is fully completed, you could actually uninstall AI Suite 2. And these settings, because it is working with the TPU and the hardware on the motherboard, are storing these settings on a complete hardware level.
So you don't necessarily need to keep the AI Suite 2 software.
Right, but if you want to take advantage of our other software functions like USB 3 Boost, iNetwork Control, Wi-Fi Go, then you definitely want to keep it on there. But if you only had purposes for overclocking, then yes, because this is an actual hardware execution function, we're just executing the initial part through software, you could go ahead and remove it.
Now, as it goes through this process, I want to shift gears a little bit to something we were talking about earlier, and that is the maximum overclocking potential of Ivy Bridge. For most home users, they're going to be using air cooling. They might be using water cooling, which isn't going to be able to get your CPU anything below the ambient temperature.
Correct.
Now, you were mentioning that some extreme overclockers, some of the folks who are using maybe phase change, maybe liquid nitrogen or liquid helium cooling, they've actually been seeing a huge jump with Ivy Bridge.
That's correct. Compared to previous architectures, there's actually an elimination of much of the cold bug issues that were present there. And the cold bug essentially allowed for a very complicated process of trying to get to a higher frequency level because the CPU was very sensitive, had to be kind of managed correctly. Under this platform, though, we've been able to get to much higher frequencies, actually getting very close to the world record frequencies that we saw under 775. So with that, with Ivy Bridge on the extreme segment, if you can keep it really cool and account for those TDP considerations, you could get upwards of 7 gigahertz.
So maybe not quite as useful for the home users out there, but if you're into the enthusiast, the extreme level overclocking competition-wise, world record-wise, we're actually seeing some pretty cool jumps going over to Ivy Bridge from Sandy Bridge.
Definitely, and as you noted, because of the architectural increases, you're getting even better performance at every one of those corresponding clock speeds.
All right, so it looks like we're up to 4.5 gigahertz now. It's a 29% boost over the stock frequency.
Correct, and that's going to go ahead and continue forward until it reaches its maximum frequency.
Okay.
Okay, so we can see here that the actual auto-tuning process has gone ahead and completed successfully, and it's given us a pretty healthy overclock. We're actually at 4.5 gigahertz. It's also overclocked our iGPU, which you can see that because we're not running a discrete graphics card, it's also going to give us an increase to gaming performance if we're using the iGPU. And if we also go ahead and reference our Ada CPU ID tool, we can see that it's also gone ahead and increased our memory frequency, which is normally on most memory kits defaulted at 1333, and now we're actually running at 1968. So in 3 ways, the auto-tuning process has gone ahead and increased the performance of the system. So it's a really nice and easy way to go ahead and be able to go from the stock level operation and go ahead and get a safe and assured way of being able to get more performance from your system.
So we're seeing a 29% increase here. We got a multiplier of 43. The B clock is up to 105.4. And you mentioned you guys have done some more with the B clock overclocking as well?
That's correct. We've made some hardware adjustments as well as some tweaks and some tunes to the UEFI to allow for some digital scaling that also the architecture allows for. So on this platform, you will see a little bit more adjustment scaling that you're going to have in terms of BCLK adjustment.
And one other thing, just for reference, the stock frequency of the 3770K?
It depends on the configuration. In our optimized multi-core enhancement, it's going to be 3.9 gigahertz.
Okay.
In other configurations, it'll be less than that.
Okay. And from here, as we were mentioning before, you could use this as a starting off point. A couple other options for overclockers out there. You do have the overclocking from the operating system available, or overclocking from the UEFI.
Correct.
Could we take a look at some of the overclocking software based from within the operating system?
Most definitely. So from here, we can go ahead and go to AI Suite and go over into the DigiPlus power control. And this is, of course, going to give us all our CPU-centric, VRM-centric power controls. So for overclockers, you could go ahead and click like this OC Now button, and this will open up a lot of parameters that are normally locked and more conservative in terms of like load line calibration or OCP controls, things like that. Or actually, while we're covering overclocking, for people that maybe want to just run at stock but have more power efficiency, they can actually pick CPU target packages in terms of the wattage, like 45 watts or 35 watts.
So without losing speed, you can lower the wattage. It's going to lower temperatures. It's going to use less power.
Well, there might be an adjustment actually in relation to the frequency, but yes, there's also going to be adjustments to voltage staples and things like that.
Okay.
But what we want to look at here is going to be some of the CPU-centric controls, right? And so we've got all the options here like load line calibration, CPU current capability, phase management adjustment, even some new options that are actually going to be like on the second tab here, like CPU power thermal control, which actually controls the VRM throttle junction temperature. So on the top of the board, right, where you have a VRM assembly, that section we can actually modify what's going to be its temperature point at where it could induce throttling. And that's going to be important because maybe your CPU is effectively still cool, but the VRM assembly might be actually reaching too much heat.
Okay.
But in terms of, let's say, making an adjustment, right, let's go ahead and take a look at TurboV Evo and maybe modify the modify the multiplier to see if we can go ahead and get a little bit more out of it.
Okay.
Okay. Okay, so now that we've gone ahead and moved over from our DigiPlus power control, we're now in TurboV Evo. With TurboV Evo, this allows us to pretty much access all the, let's say, frequency-oriented related controls for overclocking. Now, one of the new options that we've gone ahead and implemented here within the CPU ratio is group tuning. So group tuning is essentially the option to allow you to go ahead and lock in all the cores and scale them accordingly. So if, let's say, I want to go ahead and click on this, and I went to, like 4 gigahertz, and I want to apply, it's going to go ahead and essentially apply 4 gigahertz to all those cores simultaneously. Now that's possibly, though, not always the right way to overclock, because some of the advantages you have if you don't use a group tuning is that you could go ahead and, let's say, assign an overclock of, let's say, 43 to one core, and then you could go to another core and choose 42, and then for the other two you could go ahead and choose 41. The advantage of that is that you could go ahead and have more consistent voltage that would drive all the cores at 41, but essentially would also be the same voltage that would be required to drive that one single core at the highest value that we defined at 43.
And then if you're running, for instance, applications you're actually putting a load on the CPU with, if you only had a single or double or dual-threaded application, then you're still going to get that speed, and you're not going to have the additional power used up by those other unused cores.
That's correct. So essentially it allows us to go ahead and account to have more efficiency relative to voltage, as well as an overall reduced temperature footprint, because of course one core, even at the higher frequency, is going to be significantly less hot than all cores at a higher frequency.
Okay.
Okay, so let's go ahead and try to go ahead and just go back to our default parameters, and we're going to go ahead and do some quick checks which show the versatility here of working within the software environment. So the first thing you would want to go ahead and do is, let's say, go ahead and open up a stress test application. We have Ada on here, but just for reference, we could do something, let's say, like Cinebench, right? And essentially just have one single core where we're just going to go ahead and take a look at what our voltage might be. And the reason why that's important is because it's going to help you to understand what might be the load line calibration table that you're going to go with, right? Because we know at this point we have droop, right? Mm-hmm. And droop isn't necessarily bad. You just need to know how to account against droop, okay? So here we can see here we have our corresponding voltage. And if we go ahead and hit the CPU, we're going to go ahead and get a more consistent frequency, right? And then with that corresponding voltage. So we can see right there we've got about 1.128 in terms of our voltage table, right? So we know if we then go ahead and define a voltage, we might need a corresponding load line calibration to keep that more consistent as we clock up, right?
Okay.
So we can go ahead and cancel that Cinebench run. That gives us an idea of what we have there. And we can go back and we can make an adjustment to, let's say, the CPU voltage. So let's go ahead and go up to, what we discussed was our previously defined maximum, if you remember.
Yeah, 1.3.
Yeah, so we could we could choose 1.3. Okay, so now that we've gone ahead and chosen 1.3, we would then want to go back and same thing, see what's the droop characteristic. Now keep in mind that as you raise your multiplier, your voltage actually goes up as well. This is linked to what's called the VRD. And this is actually the voltage policy that the CPU has attached with it. And this is an important consideration to make because you don't want to provide more voltage as required, especially with the sensitivities and temperature output that we discussed before. Okay? So
this is a good way to determine the voltage you should set.
Yes. I mean, we already kind of know what our target is that we want to work with, but this is helping us to understand things like droop. So we can go ahead and click run at this point and then see what our corresponding voltage is again. And we can see, right, we have a droop coming into effect. So we're still underneath that 1.3 voltage that we set because there's inherently no load line calibration occurring.
Oh, okay.
And now at this point, if you wanted to try to go ahead and compensate for that, right, so stay a little bit closer to that, we could go back and go to the Digibus power control, set that to maybe like medium or like high. And what this is going to do is help to compensate against the droop. And the great advantage of this is all being done real time, right? Normally, to do all these other functions, you would have to have continually gone into the UEFI, set it, reboot, set, reboot, set, reboot, set, reboot.
So using the software-based Windows environment, you have the advantage of making all these settings. You're right there. You don't have to wait for the reboot every time and then rerun the rendering test or whatever load you're going to put on the processor.
Exactly. So at this point, we can see more or less that we have now an approximate voltage level that we're looking for, right? We know what we're working with there. And just to go ahead and give us a little bit of flexibility, let's go ahead and extend the overcurrent protection because we are raising up our voltages. Give us a little bit more wiggle room. We'll apply that, and now let's go ahead and ratchet up the clock frequency. So we'll go ahead and just for reference, we'll just go to a group tuning environment, okay? And at this point, we could, let's say, maybe go to like 4.7, okay? And we'll give ourselves, maybe one bump more, and go ahead and apply that value. And when we look down here in the multiplier, we'll see that there's going to be a change of 4.7.
So up to 4.7, I noticed the core voltage also now is up to 1.4.
Right, and that's where I was telling you that we want to be careful, right, as we raise the multiplier. And this is why you want to check things, and it's actually more functional to do it actually within the operating system, because if you remembered, we discussed as you actually raise the multiplier and an offset voltage, you're actually raising your core voltage as well, even though you haven't changed the voltage itself.
Okay.
And so at this point, you could then go ahead and say, hey, maybe I either need to lower that load line calibration, which once again, you could just go back, and instead of maybe being at high, you could go to medium and make an adjustment to that, and you can see that there's been a drop there. Okay? And that gives you some perspective in terms of how to handle overclocking within the operating system environment, but also the advantages that it has in terms of real-time feedback, and also in terms of being hardware accurate, because it's working directly with our UEFI and our TPU hardware.
So some great advice there on maintaining voltage as well as overclock from within the operating system environment. Now, for the old school overclockers out there who've been doing it for a while, it's hard to get away from that BIOS or UEFI basis for overclocking, and I know there's a lot of features in there as well. You guys have worked a lot on your UEFI. Can we take a look at that as well?
Sure. Okay, so we've gone ahead and rebooted our system. And we're going to, in a moment here, go ahead and actually enter into the UEFI. As a baseline, we're going to go ahead and load our defaults.
Okay.
And from there, we're going to go ahead and work from the baseline frequencies that are available to us. So just hit delete to go ahead and enter into the UEFI. Now, I do want to point out we have a great option called our shortcuts, which we could just press F3, and F3 will take us directly to key parts of the UEFI without even having to navigate there. So take, for instance, if we wanted to go ahead and make an adjustment to the CPU configuration, such as, like, let's say, the thermal monitor, or if you want to go to the Digital Plus power controls to change things like load line calibration, you could just use that quick shortcut option.
Pro tip.
Okay, so from here, we're just going to go ahead and default everything and go to essentially that baseline. Now, as a baseline, it does goes ahead and lets us know what our corresponding frequencies are already here in terms of the CPU turbo mode and the DRAM speed, right? So we've got this awesome kit of G.Skill Trident memory, Trident X2800. So let's go ahead and enable the XMP profile.
And that's up to 2800.
2800, correct. So we're good to go there. And we do have a special multi-core enhancement function, which essentially has all cores run at the same fixed value instead of using the normal Intel ramping policy. For overclocking purposes, though, we could go ahead and just disable this because we're going to manually define which parameters that we want to go ahead and execute.
Okay.
And for the turbo ratio, we can go ahead and just set that to manual. And we go ahead and we have a synchronized control, which essentially will link all the cores, right? And so those are all now set to 48.
All right, so 4800 megahertz effective overclock speed.
Correct. For PLL over voltage, very similar to previous generations, it can sometimes help to extend the frequency. But for the purposes of this video, since this can potentially cause issues with sleep or hibernation, we're actually going to go ahead and disable this because we know our CPU is capable of this.
Okay.
If you run into a situation where maybe the CPU doesn't go past, let's say, 46 or 47, you can enable this and you might be able to go ahead and get further overclocking headroom, but keep in mind you're going to pay the price in terms of having potential issues with S-states.
Okay.
Okay, so we'll go ahead and disable that. And for the most part there, the board is then going to go ahead and make real-time adjustments to a lot of the other parameters that are key. But we do want to go ahead and, let's say, make an adjustment in terms of voltage. Now, we discussed using an offset versus a manual voltage. If I go ahead and select manual, and now manually go ahead and define my maximum, let's say 3.50, we're going to go ahead and let you know that it's already starting to get to the caution area of it being a dangerous voltage level. I think overall we're going to be okay, but keep in mind that with a manual voltage, it's going to keep that same exact voltage whether you're at the idle frequency or at the peak frequency. So it might make more sense for you to spend the time to start with an offset voltage and then slightly incrementally increase the offset voltage, so then that way you have more efficiency. And that's one of the advantages that we discussed in the auto-tuning mechanism.
Now with the offset mode, you can assign an offset voltage for to basically provide more voltage to the processor as it's going through the overclock.
Right.
The one question I always have here is where does the voltage start at?
The baseline is essentially what you're seeing here, but as you raise your multiplier, every time you raise the multiplier, there's a new voltage that's attached to that multiplier. So therefore, it continues to offset off of that actually multiplier value. And so it can be a little bit trickier, but that's one of the key advantages of doing this in the operating system, because you could essentially just keep bumping the multiplier up and seeing how the voltage changes as you scale that up. If not, it's going to be a little bit more lengthy process if you decide you want to use the legacy UEFI. Okay? But for reference to the old school guys, I guess we'll use a non-efficient mechanism with the 1.35, okay? And from there, we want to go ahead and maybe keep a semi LLC table. So we're going to go ahead and maybe go to like a medium voltage table in terms of that. And from there, you can see that the board has already gone ahead and made certain adjustments in terms of our phase management and our current capability. So I think that we're going to be okay with that. But since we're at a little bit higher level overclock, let's go ahead and go for an extreme. The extreme is essentially just going to ensure that the power phases, since we're starting off at 4.8 gigahertz, are essentially all active in terms of assuring power phase delivery.
So a more aggressive setting for the VRM to make
Right.
sure you get
It is going to produce more heat, so you do want to keep in mind for that. Now, if we did set it to, let's say, optimize, you could potentially still use that same setting at 4.6 to 4.8. Just depends on the characteristics of the CPU and the cooling that you have in place.
Okay.
Okay, so at that point, we're pretty close to essentially being okay in terms of using these baseline results as where we want to go ahead and start with. So at that point, we could go ahead and save the results and then attempt to reboot.
All right.
Okay, so you can see we've gone ahead and booted into our Windows desktop with our 4.8 gigahertz and our 2800 memory kit on our board, and we're good to go. So let's go ahead and verify these results.
All right. Are you pulling up Ada?
Mm-hmm. And we'll just go Tools, CPU ID, and we can see that we're now running at our, let's go ahead and see, we have our 2800, and we can go ahead and, let's say, run a quick cache bench or something like that to put load, since we're running in the C-States environments. And we'll see actually our frequency go ahead and jump up there in a moment. Yeah, so you can see right there the core clock was achieved at 48.
There it is.
So we've successfully gone ahead and overclocked to 4.8 gigahertz with 2800 on the memory. Definitely a nice overclock on an Ivy Bridge capable system.
Very nice. And there's 3 different examples of how you guys can achieve some overclocking with the Ivy Bridge and Z77 platform, and particularly with the ASUS line of Z77 motherboards. I think that's going to wrap it up for today.
Yeah.
Yeah. All right. So I hope you guys have learned a little bit more. I wanted to say a huge thank you to JJ once again for stopping by and sharing all of this information with us.
Thank you very much for having me.
And if you guys want to see more, you can check out our Newegg YouTube channel. You can also check out the ASUS ROG YouTube channel if you want to see more of JJ. Thank you very much for watching, and we will see you next time on Newegg TV.